Hey, we have here to another interesting integral from the MIT Integration Bee 2012. This one here is problem number 12. We have the integral of arctan x over x squared dx. Okay, the thing that's so interesting looking at this is the denominator is so close to what we want here. If this was x squared plus 1, well, we have arctan here. The derivative of arctan is 1 over x squared plus 1 dx. For a second, I was thinking about how can I make this happen? Like, could I, add 1 and subtract 1? I just don't think that's going to do anything for us, though. I think this is just the unfortunate case where we have to deal with it. We don't have x squared plus 1, even though we want that there. But the good news is even with x squared there, it's really not that bad. I think we can just do integration by parts with this, and it's still going to be, it's going to be longer, but it's going to still be okay, I think. So I'm going to do integration by parts using the DI method, tabular integration. I don't really have an easy way to integrate arctan, so what I'm going to do is we'll differentiate arctan, and I'm going to integrate this 1 over x squared here. So then I'll differentiate arctan. That's going to give me 1 over 1 plus x squared. And then here we'll use power rule on this. When I integrate this, I can write it as x to the minus 2. Integrating that's going to give me minus 1 over x, or x to the minus 1. So then we have part of our solution right here on the diagonal. So I'm just going to write that down. So we're going to have a minus in front, arctan of x over x. And then here we'll do minus times minus, going to give me a plus. And this row is going to be an integral. And I'm going to write this as, we'll just multiply x times, I'm going to reverse the order and write it as x plus 1. I don't know. But then for this thing, what I'm going to do is partial fractions on this. I'm just going to kind of create a 1 here in the numerator, and I'm going to break it out separately. So I'm going to write it like this. We're going to have 1 over x times x squared plus 1. I'm going to split this up. And I'm going to split the x up, and we'll have, that's going to be linear, so we'll just have one term here, a constant a. And then for this other term, x squared plus 1, we want 1 degree less than this, so I'm going to write this as bx plus c. Now I can use the cover-up method for my a term. What I can do is we can set our x equal to 0. Now we need to cover up this x, because if we plug a 0 in here, we're dividing by 0. If we cover it up and we plug a 0 in here, that's just going to give me 1 over 1. So we're going to have 1 over 1 here, just 1, so my a value is going to be 1. And now for my b and c value, I can use some other values here. Like I can try x equals 1 here. If I plug 1 in here, that's going to give me a half on the left side. This is going to become 1 over 1 when I plug a 1 in here. Then bx, we plug a 1 in here, we're going to have b plus c, and this is going to be over 2. I think I'll just remove the fractions on this by just multiplying by 2 on both sides. So we'll have an equation that 1 equals 2 plus b plus c, and that's going to give me b plus c equals minus 1. Next, we use 0, we use 1. I'll try another value. Let's try plugging in x equals minus 1. If I plug that in on the left side, it's going to give me minus 1 half. Then here, we already have our a as 1, so this first term is going to be minus 1. Then we're going to have minus b plus c, and then here, minus 1 squared, this is going to give me a 2 here. Again, I'm going to multiply by a 2 on both sides on this just to clean it up. So we're going to have minus 1 equals minus 2 minus b plus c. Then I'll just add the 2 on both sides, and we're going to have minus b plus c is going to be equal to 1. So then just adding these two together, we're going to have 2c equals 0, or c equals 0. So then we'll just put that right here that we have our c is 0. Then I can just go back and plug it in like here in the first equation. If I plug in c 0, then our b value must be minus 1. Okay, so now with my a, b, and c value, I'm just going to take this and go back to the integral. So we have this first piece, I just want to copy that down so we don't lose it. So we have arctan over x. So then here, breaking out the a over x, this is going to give me an integral of just 1 over x, or dx over x. And then for this other one, I'm going to take the minus 1 from the b and bring it out front here. And then we're going to have an integral of just x over x squared plus 1 dx. Well, in this one, to finish it off, I just want to set up a u substitution. So what I'm going to do is multiply by a 2 out front. Multiply by a 2 on the x and multiply by a half here. That's going to set up a u substitution. We'll set u equal to x squared plus 1. Taking the derivative du is going to give me 2x dx, which we have right here. So then integrating this one is just going to give me natural log absolute value of x. We'll have this minus 1 half up front. And then here we can see that this value here is our u and this is our du. So I'm just going to integrate this, and we're going to have natural log absolute value of the denominator, which is x squared plus 1. But x squared plus 1 is always going to be positive, so I can remove these absolute values just because it's not necessary. I'll add a plus c on the end, and that's going to be it. Okay, so I think you can see even though it was quite a bit longer than if we had x squared plus 1, it was still really straightforward, just a few extra steps. So I'll stop it there. Thanks everyone for watching today. Please like and subscribe. Have a great day.